So hopefully you paused that video and you've gone and watched the video of me in the lab and you've seen a few things happening. So let's just recap with air pressure as to what is kind of going on. So when we deal with air pressure, there's lots of different variables that link together, which is what we'll be doing over the next few lessons. Okay, so here is a box, a container, has no particles in it. What I can do is I can throw some particles in, and there they go. And we can see them all, like, you know, they're bouncing off each other, they're bouncing off towards the container. There's some that are moving slow, some moving faster. So we have this rapid random motion. And what happens is there's this link between various different things. There's the pressure the gas the pressure of the gas exerting, which is a reference to sort of like all the force of all the collisions that have added up over the air thing. We've got the size of the container itself, so we can make this container bigger, and if we make it bigger, we can see what happens to the pressure. Well, look, pressure is lower. We can make it smaller, and that makes sense because you're either having more collisions or fewer collisions every single second. So at the moment, more collisions. If you make the area a lot bigger, make the volume a lot bigger, there are not so many collisions per second. So we've got this idea of how big the container is. But we can also do things like we can heat the gas up. We can let's start warming it up, and we'll find that the particles now will move faster and faster and faster. So we get an increase in pressure there, and we've got an increase in temperature. So there are lots of things that are linked together when we study gases. We're looking at, what is the link between, even on this one, there's that one. Oh no, it's slow again. There's a slow one. So we've got these collisions, we've got different things. We can make things more complicated by throwing some heavier particles in there as well. But everything at its heart comes down to these collisions that you can't really see, and that's what causes pressure. And there's a link, as we'll see, between how hot the gas is, what its temperature is, so how fast the particles are moving, which also affects how many collisions there are every single second. How big the container is, so if you make it a bigger container, you don't get so many particles, and the actual pressure itself. And also there is a link of how much there is in there, and all these things link together. And if we lower the temperature, you can see the temperature going down, things slow down, still with a random distribution of speeds, and that's kind of the things that we are looking together. Now, we can see this because obviously we can see with our eyes, like, because this model has given us some particles to look at. But the thing about particles is that, well, they're hard to see, they normally look like that. So it's difficult to see. And so what happened in 1905 was Albert Einstein observed something, or he managed to explain something called Brownian motion. And so I'm going to post a little video to finish off on a thing called Brownian motion, which is our other kind of evidence that this is sort of going on. There's a couple of little videos showing Brownian motion, because although we can't see these particles, if we put something in here that we can see, a big enough particle to see through a microscope, well, at that point you can then start seeing the impact of these things colliding with other things. And that is what we will see, and we'll play with this. We'll play with this in the future, and we'll look at the laws that link all these things together. Okay.